This is section 6.5, average value of a function. So let's see this example here. So they start us off with the formula. It says that the average value of f on an interval from a to b was given by this. So that's average value of the function. And it's given by 1 over b minus a, integral, from a to b of the function times dx. All right, so in general, like say, for example, these were temperatures. So there's infinitely many temperatures between 0 and 24 hours. And they want to know what the average temperature was for that day. And it appears to be this red line. That's the average temperature, and that's what we're trying to find. And this is how you would find that average temperature, by using this formula. So in general, we're going to use that for this first example. It says find the average value of the function. So they give us the interval from 1 to 3. So that's going to be our A and our B. And so the average value of this function will be 1 over 3 minus 1, integral 1 to 3, of the function t over radical 3 plus t squared with respect to t. So this is the setup. This becomes a half. We're going to have to do a u substitution here. We're going to have to solve this integral by substitution. So I'm going to let u be the integrand, or the radicand, which is 3 plus t squared. And then when I differentiate, I'm going to get 2t dt. And then I have to get rid of the 2. That means I'm going to divide both sides by 2. So it'll be t dt. So as you can see, I'm going to substitute this out and replace it with 1/2 du. This is going to become the square root of u. So I'm going to rewrite the integral as 1. There's still the 1/2 on the outside, and then we have this part is now gone, and that becomes 1/2, and then this becomes u to the negative 1/2 with respect to u. So I replaced this part with the u. That was our substitution, and because it's in the denominator and I want to move it up, and I want to get rid of the square root, I changed the square root to a half, and then I moved it up, and that's why it's negative now. So these two 1/2s become 1/4. And then the new limits, because I did a u substitution, that means I have to change my limits of integration. So I substitute 1 into t. That's going to be 4 for my lower limit. Then I substitute 3 into t. That's going to be 3 squared 9 plus 3 is 12. And then the antiderivative of u to the negative 1/2 is, that's going to stay the same for now. The next step, I will find the antiderivative, which is 2u to the positive 1/2, from 4 to 12. And don't forget, we still have that 1/4 in the front. So this is going to become, I can go ahead and cancel that with that. That's going to become 1/2 on the outside. And then it's going to become radical 12 minus radical 4. And then this is 1/2. That's 2 radical 3 minus 2. And as you can see, the 2's will cancel, and that'll become a 1. So our final answer is radical 3 minus 1. So that is the average value of the function. All right, let's look at the next problem. So they start us off with the mean value theorem for integrals. They're saying that if f is continuous on this interval, then there exists a number c in the interval such that this would be true. So in other words, there is a value, the average value will be taken on somewhere between a and b. As you can see, as long as the function f is continuous, it has to cross the average value at some point. So that's where it happens at c. All right, so as you can see, this was just b minus a, and then they multiplied both sides of the equation by b minus a, and that's why it's on this side now. All right, so for this one, it says find the average value. So we're going to do the same exact thing that we did in the previous example. So that would be f average value is going to be 1 over 3 minus 1, integral 1 to 3 of the function. And that should be pretty straightforward, because we know that the antiderivative of 1 over x is natural log. We're going from 1 to 3, so that's going to be 1/2 ln of 3 minus ln of 1, but this is 0, so it's simply going to be 1/2 ln of 3 is our answer for part A. All right, moving on to part B. So for part B, they're asking for find C such that the average value is equal to f of C. So we're looking for the value C. We're looking for this value, which would indicate that's where the average value takes place. All right, so, well, we've already done the left side. We've already done this. It's 1/2 ln of 3. So that's pretty straightforward there. We got the left side done. The right side is f of c. So since f is 1 over x, f of c is 1 over c. All right, so we found this in part A, and this is just a matter of plugging in c into your x, and that's how I got 1 over c. And all we have to do here is solve for c. If you take the reciprocal of both sides of the equation, that'll do it. So c is going to equal to 2 over ln of 3, which is approximately, if you use a calculator, 1.820. WebAssign might ask for the exact value, or it may ask for an approximation. So it just depends on what WebAssign asks. All right, for the final part, they want us to sketch the graph of the function and then the rectangle whose area is the same as the area under the graph of f. So the neat thing about this, the area under this curve, this area, is equal to this rectangle, the area of the rectangle, so long as the height of the rectangle is given by the c, where c represents the average value, where the average value takes place. So let's do that. Let's first graph the function. So this is part C. So if you graph the function of 1 over x, you will see that it looks something like this. And then 1 to 3 would be there. And then c, we found c to be 1.820, so that would be about right here somewhere. And then you just draw a line that's parallel to the x-axis, and then there's our rectangle. All right, so that's all they wanted us to do. So this area of this rectangle is equal to the area under the curve from 1 to 3. And that is the section 6.5.